Dear students, welcome to our science episodes. Today we are continuing discussing oscillatory motion. We know that the periodic motion is the motion that is regularly repeated in equal periods of time, like the oscillatory motion and the wave motion. And we are still discussing concepts related to oscillatory motion. Now we are going to talk about the complete oscillation. Look to this diagram from point B till A, till C, and again to A, and then to B. This is called a complete oscillation. It is known as the movement made by the oscillating body when it passes a single point in its path of motion 2 consecutive times in the same direction. So let's count together. B, A, C, and then from C till A till B. Did you notice that I pronounced the alphabet 2 times from B to A to C, and then again from C to A to B? I said every letter 2 times. This is the complete oscillation of an oscillatory body. How many amplitudes does a complete oscillation have? Let's count together from B to A, from A to C, and then from C to A, and then from A to B. It means 4 amplitudes. So a complete oscillation has 4 amplitudes. Therefore, the amplitude is 1/4 the total distance covered by an oscillating body in a complete oscillation. And the total distance covered by an oscillating body in a complete oscillation equals 4 times or multiplied by its amplitude. In the following pendulum, calculate the total distance covered by the body during 3 complete oscillations, knowing that the distance AB equals 5 centimeters. Now we know that the total distance covered equals 4 times the amplitude. So in one oscillation, 4 times 5 centimeters gives us 20 centimeters. The total distance covered in 3 oscillations equals 20 times 3 equals 60 centimeters. In another word, 0.6 meter. Now calculate the amplitude of a simple pendulum that covers a total distance which is equal to 80 centimeters in one complete oscillation. We know that the amplitude is equal to the 1/4 of the total distance covered by the body in a one complete oscillation. So the amplitude equals 1/4 times 80 equals 20 centimeters, which is equal to 0.2 meter. We already discussed the amplitude, the complete oscillation, and now the periodic time. From the title, periodic time, it is the time taken for an oscillating body to complete one complete oscillation. And of course, it is measured in seconds. Here is the equation. Periodic time equals time in seconds divided by the number of complete oscillations. Now, what is meant by the periodic time of an oscillating body is 0.1 second. This means that the oscillating body makes a complete oscillation in 0.1 seconds. What is meant by the time for a spring to make 60 complete oscillations is 1 minute. If you look to this diagram, this is the spring, the A is the point of rest, B is the maximum displacement, and this means that the spring will keep moving and the weight will change its position from the point of rest till the maximum displacement from A to B, from A to B, complete one oscillation in 1 second because This spring is making 60 complete oscillations in 1 minute. But the periodic, remember that the periodic time is measured in seconds. Frequency is known to be the number of complete oscillations made in only 1 second, and it is measured in hertz. Here is the equation. Frequency equal number of complete oscillations divided by time in seconds. What is meant by the frequency of an oscillating tuning fork is equal to 256 hertz. This means that the tuning fork will make 256 complete oscillations in 1 second. An oscillating body makes 60 complete oscillations in 1 minute. Now we have to change 1 minute to 60 seconds, and then the frequency equal number of oscillations divided by the time, so 60 over 60, which is equal to 1 hertz. Notice that the relation between the periodic time and the frequency of an oscillating body is inversely proportional. Knowing that the periodic time equals the time in seconds divided by the number of complete oscillations, and the frequency equal to the number of complete oscillations divided by the time in seconds. So, can you notice that they are the opposite to each other? So therefore, the frequency times periodic time equal 1. And periodic time equals 1 divided by frequency, and frequency equals 1 divided by periodic time. So that's why the relation is inversely proportional. Now let's solve this problem. An oscillating body makes 300 complete oscillations in 0.5 minutes. Calculate the periodic time and the frequency. First, calculate the time in seconds. So 0.5 times 60 equal 30 seconds. The periodic time equal the time divided by number of complete oscillations, which is equal to 30 seconds divided by 300. It will give us 0.1 second. Knowing that the frequency equal 1 divided by periodic time, so it's 1 divided by 0.1, which is equal to 10 hertz. So this means that if you have the periodic time, you can get the frequency, and vice versa. This graph represents a simple harmonic oscillatory motion of a pendulum. Calculate the amplitude, periodic time, and frequency. We all know that the amplitude is the maximum displacement achieved by the oscillatory body away from its point of rest. What is the point of rest here? It's this line, the 0 line. So the amplitude is 0.12 meters. The periodic time equals the time in seconds divided by the number of complete oscillations. So the time divided by the number of complete oscillations. So if we will count, this is the time in seconds. So this is 1 second, 2 seconds, 3 seconds, 4 seconds. So in 2 seconds, there is a complete oscillation. Do you remember, from A to B, B, C, and then from C to B, B, A. This is a complete oscillation in 2 seconds. And what is the frequency? Remember that if we have the periodic time, we can get the frequency. It's equal to 1 divided by the periodic time. So it's 1 divided by 2, which is 0.5 hertz. Now it's time for questions. Write the scientific term. The number of complete oscillations made by an oscillating body in 1 second. Frequency. The movement made by the oscillating body when it passes a single point in its path of motion for 2 consecutive times in the same direction. This is the complete oscillation. Choose the correct answer. The amplitude is the total distance covered by an oscillating body to complete 1 oscillation. 4 times equal to 1/4 or half. It's 1/4. The periodic time of an oscillating body is when it makes 10 complete oscillations in 1 second. 10 seconds, 0.5 second, 0.1 second, 0.01 second. It's 0.1 second. The frequency of a pendulum is when it makes 30 complete oscillations in 6 seconds. 5 Hertz, 0.2 Hertz, 0.5 Hertz, 8 Hertz. It's 5 Hertz. Thank you. Dear students, thank you for watching. See you later in other science episodes.